my name is Evan George, and today I'll be talking about the Third Coast Ventilator project. The two things, big news. First one is that we're finishing preclinicals today at 1. We have our final dermatology exam. It's pretty crazy. I'm excited and also very nervous to start clinicals rotations in January, but the time is finally here. Second thing is that I finally have my name on a provisional patent. Crazy. I'm very excited. Over the summer and in the fall, I was working with Dr. Swami and a group of EnMed students for an open source ventilator. It's basically a build-it-yourself ventilator to meet the shortage that COVID-19 basically created, right? So the project's debut was on Pumps and Pipes. This is a conference where Houston Methodist, NASA, Rice, and a bunch of other companies got together, and they're all talking about cool projects that's happening around in the area. So Dr. Swami gave the presentation, and one of the things he had asked me to do was to make this short video. Like while exams were going on, while classes were going on, I went out, got some footage. Some other team members were sending me footage and like over email that they did on their computers. So I kind of quickly put together this video, and we got to premiere it on Pumps and Pipes. So here's the video, and I hope you enjoy.
And early in the pandemic, we were watching Governor Andrew Cuomo ask for ventilators. I thought that Tim would be able to design one, and I asked him, I said, you could build a ventilator.
So we really put our minds together. We built a prototype in our garage, and that's where the story starts.
And I started out on this project when I answered a Facebook message from Dr. Swami. He posted a ventilator idea he was doing because of the shortage. He, at that time, incorporated more knowledgeable people with technicians and doctors and engineers, some of the finest I've ever worked with, and they have developed this into a great device that we've had to, of course, graduate into microcontroller and processing. When we did that, we pulled in some amazing students from the local colleges that were able to really take charge in this and develop the ventilator into a beautiful device that is able to help save lives around the world.
From the garage, now the Third Coast Ventilator project is on its way to the hospital setting to save lives. Let's look at this video to see how it exactly works.
Dr. Swami reached out to the EnMed program for help on the ventilator project. The EnMed program offers engineers a medical degree in hopes to spark innovation in the field. Third Coast Ventilators allowed us a unique out-of-classroom experience in medical device design that highlighted the integrated nature of EnMed. While learning about the pulmonary system, we were able to incorporate engineering lectures for a real-world application. When we joined the team, they needed help with the computer science and electrical engineering aspects of the project. They were having trouble getting the exact timing for opening and closing of the solenoid valves. And this is important to ensure that we can get the predicted tidal volumes and that there isn't pressure buildup in the system.
So one addition that the EnMed engineers made to the overall project was we put in a pressure regulator valve that is able to hold the whole pressure of the system below half a psi, which is really important because we don't want to overpressure the system. And this happens as soon as air comes off the wall before it passes through the first inspiratory valve.
In addition to optimizing the inspiratory-expiratory valve timing, we're able to adjust the inspiratory-expiratory ratios ranging from 2:1 to 1:4. With digital input, we can tell the ventilator exactly how much volume to deliver to the patient. We can do so with very high accuracy, and we can deliver tidal volumes ranging from 200 to 1,000 milliliters. With our addition of a simple water bucket, we can control peak inspiratory pressure. This allows us to not overpressurize the lung. We can fill the water bucket up to 30 centimeters of water. Downstream from the lung, we can control positive and expiratory pressure. We can control these pressures between 1.5 and 20 centimeters of water, and this allows us to keep a baseline pressure within the lung so the lung does not collapse on expiration. Our design allows us to digitally control respiratory rate, which has been tested from 12 to 30 breaths per minute. A recent improvement to our design is a 3D printed compact box. This box has an LED screen mounted to the top and wires connected to the Arduino from the LED screen. We also have holes in the box that allows us to run tubing through, and the solenoid valves are housed within the box.
The ventilator industry could not keep up with the increased demand for ventilators, in part because most companies use the same manufacturer for parts. Given this, we wanted to build a ventilator out of parts that were not part of the normal supply chain and that would be readily accessible in most hospitals. Cost was another constraint. The average ICU ventilator can cost up to $30,000. In order to make a ventilator that was accessible, we knew we had to make something much cheaper.
The total cost of the components is currently under $1,500, and our aim for the device is to help COVID-19 patients in mild to moderate respiratory distress and free up ICU ventilators for use in patients with more severe ventilatory requirements like acute respiratory distress syndrome or ARDS.
From really the moment that Third Coast was pitched to us at EnMed, I could see that this project was one with significant potential. Taking something as complicated and expensive as a ventilator and flipping it open source at 1/100th of the cost is just enough to make any engineer feel incredibly fulfilled. And it's been a real pleasure to work on this project.
Now that our design has been validated, we are excited to move forward with our product and work to publicize the Third Coast Ventilator project. Our team is currently working to develop alternate configurations of the device, including one which is capable of automatically altering the flow rate based on the physician's desired inputs, and another which can monitor the machine's outputs to the patient and automatically make adjustments to ensure consistency. Our ultimate vision is to have a variety of ventilator models which can be assembled by users at any skill level and regardless of budget. We wanted to utilize parts which were easily sourced and allow users to determine which model would be the best for their purpose. Our designs do not require access to a lot of expensive fabrication equipment, such as 3D printers and PCB milling devices, because we didn't want to exclude a significant proportion of potential users who are not at large academic centers. We envision our product being used by anyone who is in need of an easily built, low-cost, robust ventilating system.
Our ventilator design is available on our website, thirdcoastventilatorproject.com. There you'll find a parts list, assembly instructions, instructional videos, and device specifications. Our device design and corresponding microcontroller computer program is accessible and available via an open source repository, also found on our website. And it's our hope that our progress will be able to contribute to helping patients with COVID-19.
So I hope that kind of explains what Third Coast Ventilator is. We did that presentation. I also was on the panel for Third Coast. I also did another panel during that conference for EnMed. I, got to talk about how great this opportunity was and how much I learned from it. One thing I'm very thankful for is Dr. Swamy for giving us the opportunity, and my EnMed teammates who really pushed me and really helped me along. So I'm really thankful for my team. I can't thank you guys enough for just being good company and just being so awesome. One thing that I do want to say is, so we did debut it on Pumps and Pipes. We also have the patent. We published it as well on Hardware X. This is a medical device journal. So it's kind of out there in different platforms. Below is the website. So the information we have out currently is one of the first iterations that we have. We just kind of wanted to get it out there as fast as we could. So even when you look at the code is very simple and straightforward, just open and close valve. But we have worked on different functionalities such as pulse width modulation. We've done stuff with an ESP32 where you can remotely control the ventilator via Wi-Fi. So if you have a COVID-19 patient in a room and you don't want to risk exposure, you open a workstation computer and you manipulate the ventilator values from afar. So we are working on some other cool things. I'm really excited to see where this project goes. I'm also, again, just excited that I got my name on a patent, which is crazy. I would like to say that this video is not only just to tell you how excited I am for this opportunity, but also to kind of give you insight that these are the cool opportunities that you could be doing when you join EnMed, right? Like whether you join this project later on down the line and you make it 12 times better than we did, or that you're gonna do some other cool opportunity with another doctor changing this healthcare space. So again, this video is also to inspire you guys, to give you ideas of what EnMed could take you and what you could do with EnMed. I was super excited to talk to you guys about it, but I had to wait till the provisional patent was filed. Overall, EnMed has been giving me great opportunities and helping me work with great people. Excited to be here, and I'm excited that pre-clinicals are ending like today. Please comment if you have any questions. I'm happy to answer them. I try to reply to it as fast as I can. Until then, I'll see you guys around, and play safe, have fun. Peace.